Section 2.3, Example 11. Solve equations using the permutation formula NPR equals some constant number k, where n has to be greater than 0 and n has to be greater than r. So that's just saying that all of these numbers have to be a positive natural number, and the number here, n, has to be bigger than the number there, okay? N has to be greater than r. Let's take a look at A. Solve NP2 equals 30. So first of all, I'm going to write the permutation formula. The general formula is given, n factorial over n minus r factorial. In this particular example, we're going to rewrite using our formula where n remains n and r is 2. So we're just going to replace that into the formula. We have n factorial over n minus r, or n minus 2 in this particular case, factorial. We're now going to take a look at which one is the larger. So the one on top, n, is larger than n minus 2. So we're going to start to rewrite n factorial, starting with n. 1 less than n is n minus 1, and 1 less than n minus 1, n minus 2. And before we continue on, we notice that that now looks like the bottom. So factorial divided by the denominator, n minus 2 factorial, equals 30. We can see that n minus 1 divided by n minus 1 factorial cancels out any number divided by itself. is 1. We're left with n times n minus 1 on top, and that's equal to 30. So I'm just going to move this over here for a second to do some algebra. We have n times n minus 1 equals 30. We are going to distribute and multiply through. N times n is n squared. N times negative 1 is negative 1n equals 30. This is now a quadratic equation because we have an n squared. We have a degree of 2. So this is a quadratic equation. To solve a quadratic equation, we are going to bring everything to one side of the equation. So I'm going to subtract 30 on both sides, and we end up with n squared minus n minus 30 equals 0. So that's the key point in solving quadratic equations, is to bring everything to one side, set it equal to 0. We now have a trinomial. We are going to factor that trinomial. So what two binomials will give me n squared minus n minus 30. So just reviewing, we need a sum of negative 1. So the number in front of the n is our sum. And the number at the end, the constant at the end by itself, is the product. So let's just move over here for a second. We need two numbers added together to give me a negative 1. And we need the same two numbers when multiplied together to give us negative 30. We need a sum of negative 1 and a product of negative 30. So looking at our product, negative 30, we can have 1 times 30, we can have 5 times 6, 3 times 10. So looking at those possible factors, we can see that 5 times 6 is going to work here. One of those numbers need to be negative, because when we multiply the two, it has to be a negative number. And when we add those two numbers together, we need a sum of negative 1. So we can see that the negative has to belong to the 6. 5 times negative 6 is negative 30. 5 plus negative 6 is negative 1. So the two numbers that work here are 5 and negative 6. That goes into our factors. So we have n plus 5 times n minus 6. To finish solving this quadratic equation, we're using our zero product property. Two numbers are being multiplied together to give 0. That means this first factor of n plus 5 must be 0, or this other factor, n minus 6, must be 0. So solving each of those, subtract 5 from both sides, we end up with n equals -5, and add 6 to both sides, we end up with n equals +6. It may look like there's two solutions. However, based on our restrictions above, we need a positive number. N cannot be a negative number. So we reject this solution. And our answer is n equals 6.